Hi, so we're going to show how we can go from this nearly totally fresh install of Ubuntu that you see here to a running BOINC server, and not just that, a running application on your running BOINC server. So to get started, we're just going to go to the GitHub page for this BOINC server Docker thing, and you'll see that there's a couple of requirements. You'll need Docker, make, and Git, but that's it. Those I've pre-installed on this computer. And so the first thing is going to be to issue this clone command, get the repository, and then we can cd into it, and then we run this make pull. So while this download happens, I will talk a little bit. So the key is that we're using Docker, and if you're not familiar, Docker is basically this way that you can package up an application, all of its dependencies, and all the files that it needs into the so-called image or container, and then deliver it to another computer, run it on your own computer. In any case, it's just guaranteed to work in exactly the same way that it did as when you built it. So that's what's happening here. I've pre-built a number of containers that run the BOINC server, and I'm sending them to this computer, or it could be your computer if you try it out yourself. Now, Docker is kind of like a virtual machine, but it's not really in some key ways. So there's no virtualization, so it's actually running at full speed. It's just sort of isolated from your system in some other ways. You can actually run your real server like this. So this example that I'm going to give you is not just something you can learn how to play with BOINC with. This is really how you can run your server. In fact, this is how we run the Cosmology at Home server, and it works well. These images, they're easy to build and to modify, to extend, and the file sizes are not that big. In fact, so we use Docker not just to run the server, but actually also to run the applications on the server, because it's kind of the perfect thing. We can build the application and deliver this container to the volunteers, and it will run. We are sure that it will run exactly the same way that it did when we tested it on our computer. And the file sizes for these containers delivered to the users can be made very small. So here, these ones that we're downloading here, haven't really paid attention to making them small. The ones for the users, though, can really be tens of megabytes for really very rich applications and their dependencies. So here, though, we're downloading. I'm not cheating at all, so I'm really just going to let this download go so you can see how long this might take. There's three containers that are being downloaded. There's a MySQL server, an Apache server, and basically the BOINC source code, which will build and configure a fully working server once it's done. So we're pretty close here. Just a few more seconds. Okay, there we go. So the next thing to do is to take these containers that we've downloaded and run them. And that is this make up command. So now this will bring up the MySQL server, bring up the Apache server, and actually build this project, which we'll then be able to look at. Alright, there we go. So now we have our running server, and we can look at it at localhost / we've named it the default name BOINC server. Now, BOINC servers have their URL hard-coded, and the default here is boincserver.com, and they actually need to think they live at this URL for everything to work just right. So we need to trick this server into thinking that it also lives at boincserver.com, and it's easy to do. I just edit the etc hosts file, and I just add boincserver.com here. Good. So now, if we head back here, the server thinks it lives at boincserver.com. Great. So we can take a look around. It's a fully running server. The daemons are going. Everything's set up. There's no other tinkering. There's an application. So let's take a look at this application. So this application is going to be what lets us run Docker images now on the volunteers. We can get a shell inside of this server with this exec apache command. So this should look familiar to you if you've ever run a BOINC project. It's just your standard BOINC things, status. Good. So now let's run an application. Before that, let's take a small detour and talk about running Docker containers. I'm going to head over to the Docker Hub and browse through some of their base images, official repositories. These are things that you can start your images and build them on top of. So you can build an Ubuntu image. You can go here. There's things like Python. For the purposes of this example, I'm going to go to page 8 and pick this perhaps slightly lesser known language, Julia, just to give you an example that you can just do whatever you want here. So we'll click on Julia. It's this language, if you're not familiar, similar to Python. It's pretty cool. I'm going to look at the tags, and I'm just going to pick a version based on the fact that the file size here is fairly small. It could be made even smaller. So let's go back here. So to run this Julia container, I would do something like this. And run. And so the first thing that's going to happen is I don't have the Julia image on my computer, so it's going to get downloaded. And once it's downloaded, it'll just drop me into the Julia shell. Good, there we go. So we've got a Julia shell now, and I can start doing whatever I want. So for my science app, I'm going to do the following, which is I'm going to print out the squares of the numbers 1 through 4. So pretty cutting edge stuff. I can do this also from the command line. I don't need the interactive shell. I would just run this command like so. And you'll see that I print out the same numbers. And also note that I didn't re-download the image because I already had it. It was already on this computer. So now we want to create a job on our BOINC server that does this command that you see here. The way to do this is this BOINC to Docker create work command. So this is meant to look like, to the BOINC experts, a BOINC create work app, and you can see some of these familiar options here. And to the Docker experts, it's meant to look like that Docker run command that we just saw. So there's things like entry point, there's the name of the image, there's the arguments. So the idea is that we just literally just take this run command that we have before, and we just paste it here and run, and we've created this work unit. So let's take a look now at the server. Look in the apps, the default password, and I can look at my results. And you see that I've created now one work unit for this job and 2 results. Looks like this. Good. So it's there. So let's actually fire up a BOINC server and connect to it, or sorry, a BOINC client and connect to this and run this job. Good. I'll do my password. I always use my name. It's easy to remember. We don't need to do that. Let's take a look. We've got the BOINC server. We've got a task. The files are being downloaded, so there's this ISO here so I'll explain in a second. And so we're running. So what's happening behind the scenes is that we've delivered to the volunteer VBox wrapper a bootable ISO that boots into an operating system that lets you that has Docker installed on it and lets you run these Docker commands. And so this Docker command gets run. The volunteer, if it's necessary, will pull the image that we needed, in this case this Julia image, and run it, and we'll see the result. So that's what's happening now behind the scenes. We'll see that we can then look at the output of this job, the standard output, or from inside the job, there's a special folder where if the Docker container just writes any files to that, they're just automatically sent back up to the BOINC server as an output file. So we should be pretty close to finishing here. Good. and ready to report, and should be sent back up to the server in a second. There we go. So let's head back to the server now and go back and refresh this page. And it looks like one of the results came back and it was a success. So let's take a look at the result. And we can see the standard output. This is really the output from this whole operating system booting up. And we get to some point where we actually run the BOINC app. You can see what happened is that the Julia image was not found. And so it pulled it just like it did on our system. Pulled it, pulled complete, so on, and then we come here and we actually run the Julia image, and lo and behold, we get our output from our science application, the squares of the numbers from 1 to 4. So hopefully it's clear that I could have done anything there, not this simple application. Any container that you create and then you push up to the public free Docker Hub will work and can be run on these, can be run using this system. So hopefully you found this cool and you see the potential. We went in just about 10 minutes from nothing to server and running application. Thank you for watching.